In this next session, we're going to look at the product rule and the quotient rule. So far, we've looked at the addition rule and the subtraction rule. So when we have two functions that we're adding or subtracting together, all we need to do is differentiate each part and then add or subtract them. Now, when we have a look at operations like this, where we've got two functions which we're multiplying together, we can't actually do that. We're going to have a look now at how we use the product rule to differentiate functions like this, where we have two different components. So if our function is u of x times or multiplied by v of x, then the derivative of x, f dash x, is going to be the first function times the derivative of the second function plus the second function multiplied by the derivative of the first function. So to try and get our heads around this, let's have a look at an example and then I'll ask you to have a go at one. So part A, f of x equals 3x plus 1 times ln of x. In order to do this then, we're going to look at our first factor, which is 3x plus 1, multiplied by ln x, and then look at it in the context of the formula up here. So we're going to multiply our first factor by the derivative of the second factor. Now we've seen already that the derivative of ln x is 1 over x. We're then going to add the second factor, which is ln x, vx here, multiplied by the derivative of the first factor. We can see that the first factor is 3x plus 1, and if we find the derivative of that, it gives us 3. Consequently, we can multiply out the brackets and we end up with 3 plus 1 over x, 3x and the x cancel out. That's going to give us 1 over x plus 3 ln x. And we can write that therefore as 3x plus 1 plus 3x ln x all over x. So I suggest that you just pause the video here and then try and have a go at part B using the same approach. So here your second factor is going to be 2x minus 1. Your first factor is going to be x to the power 4 plus 3x cubed plus 6. So let's have a look at part B then. This was our function. So if we're multiplying two factors together, we're going to apply the product rule. Here's our first factor and our second factor. So the derivative of our function is going to be the first factor, u of x, multiplied by the derivative of our second factor, which here is going to be 2, plus our second factor, v of x, multiplied by the derivative of our first factor, which is going to be 4x cubed plus 9x squared, and if we differentiate that, that's just going to disappear. So we can expand the first part here and the second part here, which is going to give us 8x to the power 4 minus 4x cubed plus 18x cubed minus 9x squared. If we tidy that all up and simplify, we end up with this 10x to the power 4 plus 20x cubed minus 9x squared plus 12. The next rule that we're going to look at is the quotient rule, which in effect enables us to differentiate a function like this, where we have, for instance, ux over vx. Again, you cannot just find the derivative of this function and divide it by the derivative of this function. That will not work. In order to find the derivative of a function like this, we have to use the quotient rule, which looks quite intimidating, but is fairly straightforward to apply. So to apply the quotient rule, you need to multiply the second component here by the derivative of the numerator, and then subtract the first the first component here multiplied by the derivative of the denominator, and divide that by the denominator all squared. So there are a couple of questions here to have a look at, which you might just try and follow through. So the first function here, we know that fx equals 5x plus 3 over x squared plus 1. So we can see then, applying this formula, that the first thing we need to do is take the denominator. which is x squared plus 1. Multiply that by the derivative of the numerator. We can see clearly the derivative of 5x plus 3 is just going to give us 5. We then subtract the numerator, which is 5x plus 3, multiplied by the derivative of the denominator, which is just going to be 2x. We then need to divide by the square of the denominator, which in this instance is going to be x squared plus 1 all squared. Now typically we won't actually need to expand the denominator. If we expand this all out then, well, expand the numerator out at least, you end up with 5x squared plus 5 minus brackets 10x squared plus 6x. We can therefore simplify that to give us minus 5x squared minus 6x plus 5 all over x squared plus 1 all squared. And as I said, we don't need to expand that. Here is another question which you might want to try yourself. So for part D, again, we've got a function where we are dividing two components, therefore we need to use the quotient rule. Analysing it in these terms again, we can see that we want to take the denominator, which is here, multiplied by the derivative of the numerator. Clearly the derivative of the numerator here is going to be 1. We're then going to subtract the numerator, which is x plus 2, multiplied by the derivative of the denominator. And we've seen previously that the derivative of 2e to the x would just be 2e to the x itself, all divided by the denominator squared. So we can expand and we can simplify that, and we would end up with negative 2x e to the x minus 2e to the x minus 3 all over 2e to the x minus 3 all squared. And that is the solution.